I see the recording has started. I'll endeavor to keep effing and jeffing to a minimum from here on in. I see we've got some AI note takers. You're very welcome, our new intelligent overlords. Just remember when Skynet takes over. I was pleased that you were here on this Gemini call. People are still coming in, so we'll just give them a couple more minutes. And we'll get going. Dan, excellent work.
Thank you.
I spent, what was it called? There's something basilisk. There's actually a thought experiment about how if you know that AI might eventually take over, not actively supporting it right now and knowing that you could have done is a recordable event. Something basilisk. It'll come back to me. I realize none of you care, but it's bothering me. Type in the notes if anyone remembers what it's called. It's the something basilisk. There we go. Is that you again, Dan?
Well, it was Google who did it for me.
Okay, excellent. Well, there we are again. Thanks very much, Google. Appreciate your efforts. Brilliant. So before we completely defer to future AI world, good morning, everyone. Welcome to today's Gemini call. I'm Ali Nichols, standing in for Simon Evans in the chair. We have a couple of brilliant presentations today. They'll each be 8 minutes long. We'll then have some community announcements, and then we'll have some Q&A with our speakers. If you have any questions, please put them in Slido. You'll see slido.com there, hashtag Gemini call. You can ask questions of the individual speakers or open it up for everyone. Please do use the chat for messaging, commentary, whatever else, but please do use Slido for questions. It just helps us keep us fair. On Slido, you can upvote those questions, so we ask the most popular questions. But what we tend to try and do is if you have any questions that aren't answered, we'll try and get the speakers to answer them offline. All the presentations will be available through the DT Hub, so please do check out ones from previous sessions. But without further ado, I'm going to ask Jayashri to present on the smart shift, digital twins driving industrial intelligence.
Perfect.
Presentation is up and in presentation mode. Excellent.
Yeah, thank you. Thanks a lot for the introduction. So good morning, everyone. This is Jayashri, and I work in the digital twin space as a digital twin engineer. And today's presentation is going to be about the smart shift, digital twins driving industrial intelligence. So I work for a British climate technology company, and their focus is to decarbonize the world's most carbon-intensive industries. And as you can see in the slide, that's how the decarbonization system is going to look like. It converts methane into two high-quality products, graphene and hydrogen. And my work involves developing a digital twin for this particular decarbonization device. So now about my project, what is the value of the digital twin? Why is it so vital for a company like Levidian? Firstly, data-driven decision-making. So currently, there's like no understanding of the run data within our organization. So developing that early culture of insights is the first most crucial benefit that we're looking for. Secondly, because we are looking, building 21st century loop, and I am using one of the most powerful cloud platform called Azure for my development. It gives us a competitive edge. Next, efficiency and cost reduction. I think that's one of the mutually inclusive benefit that we're looking for when it comes to developing a digital twin. Next comes the scalability feature, because the loop system, that is the decarbonization system, is going to be deployed across different locations, UAE, UK, North America. So I need to develop that scalable architecture for the digital twin to adapt to different locations. And finally, it's born digital. So I am building every element that's involved within the digital twin from the ground up. So I'm not using any in-house softwares or readily available digital twin softwares for the development. And when I'm going to be showing you the architecture, I will tell you what are the core elements that I'm using within my project. So now about my project, what am I developing? So again, this is not a very comprehensive architecture, but it gives the core element of what are the main elements I'm using within my project. Firstly, ontology model, and I'm sure majority of you would be using this within your organization, especially if you're dealing with digital twins. So in terms of like an industrial smart manufacturing perspective, it is a model that captures the technical properties, data properties, the functional characteristics of an entire asset or a system or a business process in a single piece of dashboard. So this is according to my definition, and it forms the core framework for organizing, defining, and connecting all your data. The second step is to develop the direct connection, that is from the physical system to the virtual system. I think that's one of the main definitions of a digital twin. So how am I doing that? It's by a direct link from the core control system to my digital twin environment. So for that, I am using this self-developed function app within the Azure ecosystem. So what is a function app? It's a serverless solution that helps us to manage less infrastructure, save less cost, and create as many as resources as you want to without the need of deploying any intermediate servers. So that's the basic functionality of this function app. And we do have like a lot of SDKs within that environment. And all of this, which will enable maintenance, prediction, and feedback. So this is a digital twin instance. Again, I'm exactly using the same environment for my digital twin. And this is an example of an arm, but here we can replace it with my system here. So towards the left, we can see the different elements, and you're able to see just 5 or 6 different elements here. But in my example, like in my digital twin use case, I have embedded around like 50 to 60 different parameters, considering temperature, pressure, voltage, power consumption. All of these values are getting updated in real time every second. So if there are field service engineers within an organization, they'll be able to look at the digital twin and immediately reflect or just change the parameters if they want to. And towards the right, you can see the state of the asset. As in, I have embedded 3 different states. That is, if the asset is in running mode, if it's in idle mode, or if it's in error mode. And if it's in error mode, it's going to be, again, similarly embedded with a different color. If it's going to be in idle, it's a different color. And in the all properties section, again, as I mentioned, along with its metadata, you can see all the values getting updated in real time every second. So what are the benefits that I've achieved through this development? So firstly, real-time asset monitoring. We're able to look at all the 50 to 100 different parameters that getting updated in real time and immediately reflect on it. Next comes the alert configuration. So I have used different APIs to configure alerts through 2 different channels, one through SMS, another alert is through Outlook. So if there's one channel that's not working, we get an alert to another channel. And what does that alert have? It has the error code, as in what is the code that is associated with the defect, along with its description of the error, along with its entire body of the message. So all of this is being reflected on my digital twin, which will lead to improved field service efficiency and enhanced operation visibility. Next comes the reporting and monitoring dashboards. So I have embedded an output connector to my digital twin called Power BI. I'm sure majority of you know. So what does it do is from my digital twin, all the live data is being fed into my dynamic Power BI dashboard. And in the time series format, we'll be able to visualize the outliers, or if there's any correlation, or if there's any thresholds within the data in real time. So that contributes to the reporting and monitoring dashboards. Finally, high quality data and reliable analytics. So as I mentioned, there was the very fussy and congested data in the beginning, but now I have dedicated containers for my loop systems, and that doesn't need any normalization, cleaning, or transformation techniques. It's a very high quality data with reliable analytics. The next phase was the machine learning phase. So I have given focus on two different elements here, which is the predictive maintenance, to be able to identify if there's any faults within the system, or to predict what is the fault within the specific asset, or in this specific time, this particular part might fail. So that contributes to predictive maintenance. Then comes the yield prediction, being able to predict what the graphene quantity would be, because that's one of the main output of my loop systems. And anomaly detection, to look into the unusual patterns within the data, to look into the positive and the negative trends of the data, and also to know what are the most important feature and the least important feature, which will all contribute to overall equipment effectiveness and efficiency optimization. So this is going to be my future vision and next steps, starting off with the component twin, which is there in the majority. I think that's the first maturity level of digital twin. Asset twin is the one that I have developed for now, a digital twin for an entire loop system. The next vision would be federated digital twin, that is having a single presentation layer and multiple different digital twins running in the background. And the clients would be able to see each and every, they'll be able to visualize what digital twin is for the multiple loops here, which will all lead to enhanced predictive modeling, automated decision making, and self-optimized products. So yeah, thank you all for your attention and patience throughout the session. Let's keep the conversation going. Thank you.
Wonderful. Thank you so much. Fantastic to see the work you're doing at Levidian. And I'm sure we'll have a load of questions. If you do have questions, pop them in slido.com, #Gemini call, get them in, and we can dig deeper into that case study towards the back end of this morning's session. So up next, we have Vicky, who has another case study. Great to see digital twins in the wild being used. Digital twin for education estates.
Everybody, bear with me 1 second while I just share my screen.
That's up.
Okay, brilliant. So good morning, I'm Vicky Reynolds from One Creative Environments, and we are a multidisciplinary consultancy. And our Smart Assets team, which sits within the Digital Estates business unit, is a software agnostic digital twin and design and configuration service. So we don't actually develop software, we design solutions and build them using a range of different tools and software based on the client's budget, technical competence, and their requirements. So today I'm going to share a live case study from our work with a multi-academy trust, which has over 30 primary and secondary schools within it. And we're helping them to transition from fragmented records, limited digital assets to a smart, scalable estate platform. So when the trust approached us, they weren't exactly sure what they needed or how it might work, but they were certain that they couldn't carry on how they were. And after many discussions about their main pain points and their existing digital portfolio, we helped them to put together a wish list. And that included a solution to centralize their asset data, remove their reliance on proprietary systems, support smarter facilities management, enable retrofit planning so that it aligned with their net zero ambitions, and it needed to be accessible to both technical and non-technical users, so all the way from their estate managers to their caretakers and their school administrators. So from this wish list, we designed an open, outcomes-led digital twin strategy with long-term scalability in mind, and this is how we started that. So first, we reviewed their existing portfolio. Asset information for them was spread far and wide, and some technology and data repositories at the individual schools were known to the trust, but a lot of them were only known to the facilities managers or on-site maintenance teams. Some schools had a BMS with smart functionality, but others didn't. And for many schools, the CAFM system was literally just a series of spreadsheets. There was no consistency in the way information was stored, organized, or labeled across the estate, and many of their processes were still paper-based. So once we had a clear understanding of what they needed and what already existed, we put together a proof of concept across 2 of their schools. And that involved optimizing some 3D models that they already had from the Net Zero Accelerator program, which was funding to get digital assets by the Department of Education, and structuring asset data using the Department of Education naming conventions. We integrated compliance documentation, surveys, and O&M manuals, and all of this was brought into an environment that became their foundation for wider estate insights. So once we were armed with the outcomes of the existing asset review and the proof of concept, we were able to put together a set of information requirements to ensure that for all future works, either new build or retrofit, data handovers throughout the project would be consistent with the requirements of their new digital estate solution. So it should be noted that we'd identified really early in the engagement that updating legacy information would be beyond the trust's budget, and the potential ROI would not be enough to justify the cost of that, hence focusing for now on the current and future works. So we produced for them the organisational information requirements, which set out the estate's strategic goals and the why behind them, the asset information requirements, which documented the individual asset requirements, including the maintainable asset lists and the data standards, and the employer's information requirements, which provided the delivery requirements for each individual project. So elements of the digital twin included dashboards to monitor energy use and identify carbon reduction opportunities, as you can see on the left-hand side. The Trust wanted plain language alerts to show the health of their assets in general. So you can see in the red section there, that's very clear language, and also a clear visual representation of the expenditure and the usage by day and by hour. So from this dashboard, they can create reports or dig deeper into the data to find root causes. And on the top right, you can see an element of their smart plan preventative maintenance scheduling function, and that was assigned at the asset level. So they could see all of the maintenance history of an individual asset and essentially do a health check on that. And the bottom right is how asset information is visualized. And that includes average uptime and the maintenance hours that have been put into that asset. So all features were designed to work for both the facilities team and the leadership team, with custom views to support accessibility for every different type of stakeholder. And even at this early stage, so we just passed the proof of concept, we're starting the rollout on the additional schools, we can see that the benefits are tangible. So their risk visibility is improved, compliance management is centralized, maintenance is shifting from reactive to proactive, and the Trust can now make informed decisions about where and how they want to retrofit. And they're also seeing real operational savings and better staff engagement. So this here on the screen is a snip from the Trust's own independent assessment of the value of the twin so far, which we didn't influence at all. They sent it to us after they'd done it. And as you can see, they've estimated approximately 223,000 in annual savings, plus a range of less tangible benefits as well. So what's next? We want to scale the federated digital twin across all the sites. We want to enhance the integration with their existing systems and develop the platform to support retrofit procurement and funding bids. So all of this is supported by training and clear asset information requirements to ensure that what we build remains usable and relevant in the long term. And our long-term goal as One Creative is to empower them to understand and host their own twin without any reliance on proprietary systems or long-term consultants. And that involves us. Essentially, we want to work ourselves out of the equation. So this project shows that you don't need a perfect data set to get started. With the right structure, standards, collaboration, a fragmented estate can become a connected strategic asset. Thank you so much. I'd love to hear your thoughts and answer any questions.
Brilliant. Thank you, Vicky. And powerful example there of the work being done. Wonderful. So while you're thinking about questions for our two presenters and thinking about how to dig into those fantastic case studies, Nuri has got some community announcements for us.
Thank you, Ali. So a couple of community announcements. So the first one is that the DT Hub is seeking presenters for our weekly call. And it's an opportunity to share your digital twin projects, research, and case studies for our new 15-minute presentation slot starting from the 9th of September. So it's an opportunity to really focus and delve on specific case studies in a little bit more detail with focused Q&A. And it's an opportunity for you to kind of join our continuing growing of our thriving community. The second announcement is that as we're taking a short break, as of today, will be the last Gemini call for the summer and will return on the 9th of September. We still want to enhance and improve our future Gemini call experiences. So please do spare a few moments to complete our survey, as your feedback is really crucial to how we shape our future Gemini call experiences. And back to you, Ali.
Wonderful. Excellent. So we're just getting the Slido questions sorted and updated, and when they're available, they'll appear on the screen for us all to see. But while we're waiting for that, I have a question for you both. In your delivery of these case studies, or the building of the tech stack, in the case of the VDN, what was a surprising obstacle that you came across, or an unexpected obstacle that you came across in trying to do it?
Okay, so one of the main challenges is to connect the physical system to my digital twin environment, because I am not supposed to be using any mediator or any broker in between. So I made use of like the existing function and libraries to do that connection. And also because there's like no proper data, as I mentioned, for digital twin, digital twin relies heavily on data. So there's like no proper data that was collected. So I had to do it from scratch. So I collected data from scratch from my digital twin, and that's how I resolved that challenge.
Excellent. Thank you. Vicky.
For us, it was finding exactly the right tools. So because we have a kind of ecosystem of tools that we use, there's the challenge of building those connections and the APIs and the distribution of the data between all the different systems. So we have to consider, when we're looking at the systems, not only the functionality, but also their interoperability, and make sure that that is aligned with things like the client's budget and their needs. So there's always a bit of a balance between, yes, this does exactly what the client wants and will display the data in exactly the right way, but it means that then we can't use this, and this, or it limits our access to these other solutions. So that's probably the most difficult part for us.
And then obviously on the flip side, any unexpected or welcome bonuses? I mean, so something you saw that perhaps wasn't. So Vicky, in your case, for example, we saw the clearly laid out operational asset and enterprise information requirements, but any additional benefits or unexpected quantum of benefit that you weren't expecting?
Yeah, one for us it's actually a different school estate, but we had a school that had set some targets for their or net zero goals aligned to their energy usage, and they found that they were significantly missing that goal over and over again, but at a very set period of time. So they were fine, and then a date hit and they suddenly dropped off and they couldn't meet any of the goals. And nobody could explain why. They were just on the verge of starting to replace some of their assets, thinking maybe they've got less efficient. And then we dug into the data and found that actually the usage was peaking around kind of 6 p.m. and 8 p.m. in a school. And we were like, well, what's going on beyond that time? And the school were like, oh, actually, I heard that someone is subbing out the hall for extra classes in the evenings. And so all of a sudden, we were able to see, right, well, those extra 2 or 3 hours of usage in the evening were knocking them over their target. They either had to realign their targets to include that, or they had to stop subbing out the hall. And I think without the data, they would have just started ripping out systems and trying to replace assets. So that was one unexpected insight.
Perfect. And Jashu, from your development of your stack, anything that you've come across that was an unexpected win or a benefit or a delight?
I think we initially did not have an idea to utilize AI incorporate AI into digital twin, but then we eventually made use of object detection, because we have 2 outputs, and then making use of object detection, custom vision technologies into digital twin, we had a sudden benefit through that. And we also incorporated responsible AI dashboard so that our users can actually look into that and also look into the carbon footprint, as in what is the carbon footprint of the entire organization or for the entire software. All of that was an additional benefit for the digital twin developed.
Perfect. Fantastic example. Vicky, something specific for you now. You mentioned that DFE had specified a naming convention. Pardon me, had specified a naming convention. Two questions. Cheeky. Would you describe that as a mandated ontology? And secondly, does the naming convention just cover assets related to the built environment?
No and yes. So it's not mandated. It is it's kind of recommended or suggested, but it's also continually under review as a set of requirements, which is a challenge then for schools or estate managers who don't necessarily understand the nuances of the naming requirements anyway, and they're consistently changing, and they haven't actually been mandated. So what we did is took what we did have from the DFE, so they do have some good documentation showing their kind of best practice. We took that, we fed it into the requirements for the estate, but with an element of kind of, so that if we found out at a later date that the requirements of the DFE had changed or shifted, we understood at the very least the mapping, so that we could map that change accordingly. So it was a bit of best practice, a bit of what we already knew from other projects, a bit of the DFE, a bit of ISO 19650, trying to pull it all together and say, okay, in this instance, this is what is going to work best for this asset.
Fantastic. There's a reference that will make Dan's heart soar. Bravo. So actually, on your side, you're doing some brilliant stuff. You spoke about the benefit of bringing AI in and object detection and so on. How did you initiate the project? How did you start to sell the benefits of the work that you were going to do in advance of getting the work done within Levedian?
Step was building a prototype, like a mini prototype, and then show them that these are the benefits, and this is how you can monitor the data within the asset and how the data is going to be live streamed. So I was like a mini prototype using like a simulated data, not like an actual data. So using that prototype demonstrated the benefits, and the clients and the stakeholders, they understood what the benefits are. And then I moved on to developing an actual like model. So that is how I moved from like a mini prototype to an actual model.
Brilliant. Taking them on the journey with you. Fantastic. Wonderful. Well, apologies we've had some issues with Slido this morning. So apologies if you put a question in Slido and missed it. If you did and you want to quickly drop it into the chat, please do. So I'll just wait 30 seconds to let someone copy and paste. But failing that, thank you both very much for your presentations. Fascinating, brilliant to see the work being done in the wild. Great to see some actual technology stacks from both of you in terms of what's actually happening under the hood. And Vicky, wonderful to see those statistics on ROI and both the soft and hard benefits that you see within the education estate. Just a reminder from Nuri's community announcements, we are now on break until the 9th of September. So if you turn up next Tuesday at 10:30, you're welcome to sit on a Teams link, but unfortunately not a lot will happen. I hope you all have a fantastic summer. Enjoy August. Hopefully the weather improves for us all. And we will see you back here Tuesday, 10:30 on the 9th of September. Thank you all very much.
Thank you so much. Bye.
Bye.
Thank you. Bye.